So we're going to use mods to solve this problem, which initially seems very difficult, but it's not that difficult at all. So first, let's go ahead and introduce what we're going to use. First, we're going to have to use a rule of mods we haven't learned yet. So the rule is that if A is congruent to B mod C, then we know that A to the n is congruent to B to the n mod C for n is some integer that's positive. And let's see why that's true. So if the first statement is true, that means that A minus B over C is an element of the integers. That's what mod means. So does that imply that A to the n minus B to the n over C is also an element of integers? It actually does, because if we just factor out, because going back to your Algebra 2 class, we can factor out A and B from here, A minus B, because if we factor out A minus B from here, then we're going to get A to the n minus 1 times B to the 0 plus A to the n minus 2 times B to the 1 plus, and that's going to go all the way to when A is to the 0 and B is to the n minus 1. So we can factor out A minus B from there. So that means that A to the n minus B to the n over C can be reduced to, that equals A minus B times A to the n minus 1, all that stuff, over C. And we know that A minus B over C is an integer, so we can just replace all this with an integer sign. So an integer, and this whole other part is an integer as well, because it's just multiplication, addition of integers. So the end result is also an integer. So that means that A to the n is congruent to B to the n mod C. Now that we've established that, this problem becomes very simple. So we know that 999,999 is congruent to negative 1 mod 1 million. Okay? And this is true because if we take 999,909 minus negative 1, that gives us a million. Divided by a million, we get 1, which is an integer, so that's true. Now, if we raise this to the power of a million, so we're going to raise it to the power of, we take 99999, raise it to the power of 1, 2, 3, 4, 5, 6 zeros. Then we have to raise negative 1 to the power of 1 million, which gives us 1 mod 1 million. And that means that it's going to be, this number is going to be, when we divide it by a million, it's going to give a remainder of 1. And the only types of numbers that do that are, the number has to look something like this. It has to be a bunch of numbers, up front, blah, blah, blah. And the last digits have to be 0, 0, 0, 0, 0, 1. And the reason is because when you divide that by 1 million, then we can break this up, because you can just take this 1 off, replace it with a 0, and add that 1 over here. I'm going to write in compact form, 10 to the power of 6. If we just do that, then these zeros all cancel. So this part is an integer, and this part just gives a remainder of 1. So that means the last 5 digits are 0, 0, 0, 0, 1.